how was that kind of moving into different roles of engineering, going into systems engineering, of kind of wrangling together a lot more engineers? Because I guess one of the things that I remember from my third summer is that the systems engineering part of it was a lot more prevalent than before, and what it was a lot better defined, and it's something that I'd never seen before, which I thought was really interesting. It was a really kind of different way of thinking about how to organize kind of the product that we're building. So yeah, so I guess I don't know. I think there's a few questions in there, but can you just talk a little bit about that?
Um, yeah, well, A3 and A6. I mean, systems engineering is done in any project, whether you call them systems engineers or not. It's the process by which you bring multiple people together to design something that is too complex to be designed as a whole, right? You have to break it up into some kind of components. Now you have to start making sure that those components are compatible with each other. And then you got to sometimes take those components and break them up into smaller components so you can think about it, because it's just too complicated of a problem. And now there's so many components, you need other people each working on their own components. And somehow you need to bring these all together in the end, and it all has to work. And so that's done regardless of whether you have a systems engineering team or not. But that's essentially the goal of what systems engineering is to have a formalized process for that, for attacking these complex projects. We didn't have a strong formalized process for A3 and A6. It was more of a capabilities driven, in a lot of ways, which was we wanted, we're going to, rather than having a top down set of requirements of like, it needs to communicate, this many bits per second, and it has to store this much power, and it has to point this well. Since again, we were trying to architect the system, it was more of what are the architectures that we want? How do we want messaging to, what do we want messaging to look like? And then what came out of it was, well, how well can we point? It was kind of a bottoms up approach to engineering, where we started with all the low level things and we just started, kind of building it all together. And then what emerged was its capability. I'm being a little bit unfair to it. It was, more than that, but I want to contrast that with what we were doing when we left, when the program ended, which was we were designing our very first deep space mission. And that had scientific and programmatic goals that we needed to meet. And now that you have this sort of top level objective, you can't just start building things from the bottom and being like, well, let's see what sort of capability emerges. Now you have to do this process of exploring concepts. What is the best concept to meet these high level objectives, right? We want to image an asteroid. Well, can we do that with a ground telescope? Why are we even messing around with satellites? Oh, we can't because the atmosphere. Okay, well, can we image it from an Earth orbiting spacecraft, right? It's close to Earth. It's going to be a lot easier. It doesn't require as much delta V. Can we just do that? No atmosphere. It's like, oh, probably not for these reasons. Okay, now we need to go there. So you start honing in on these concepts without actually even setting requirements at this point. You're just exploring all of the different ways that you can meet these objectives. And that's, part of systems engineering. And that's what we were doing, as well as starting to set high level performance requirements on the system. And that was just a very formalized approach to engineering that we hadn't taken really on A3 and A6, but mostly because the nature of the objectives were coming from above, this high level objective that we needed to meet. So we had to decompose the problem from the top down rather than a bottoms up with, determining what capabilities came out of it. So that's why when you came back, you probably realized that there was a stronger emphasis on the process and requirements and that sort of thinking about the problem that we hadn't really emphasized before.
Mm-hmm. And another thing that I found interesting, kind of along those lines of systems, that was already being done in the A3 and A6, I believe, is the concept of having a product owner. I thought was kind of interesting. And is did you see that say at Boeing or somewhere else, kind of like that concept of having a person own a product, so it's like kind of their baby, and it's not like they're solely responsible because obviously you get the help of a lot of other engineers, but at the end of the day, they're the ones that are reporting on that product.
Yeah, I mean, there's this idea of ownership that we saw at Boeing, probably most everywhere, right? If nobody feels like they own a product, there's nobody really going to be advocating for it. And it's just going to kind of go along for the ride. And everybody's going to be like, well, I did my part, but I'm not responsible for it, you know, and then all sorts of things are going to get missed. And so it's helpful to set up a program in such a way that every product, whether that's a software component or hardware or a process or something like that, there's somebody who feels like they own it and it's theirs, even though nobody can really ever do anything on their own because it's just, most things are just too complicated. And so it's there's, you know, a small team, but somebody might be writing, you know, doing layout for the PCB for several components, right? And they want to do a good job because everybody, you know, typically does, and they want to do, you know, they want to make sure that the layout is right, but they're being stretched across multiple products, right? And they may not know all of the specific details and the requirements and the like operating conditions and the use cases and all of that kind of stuff. So sometimes it just takes the person who is like, this one component, you're doing the layout for me, but I'm the one that like really needs to make sure that this thing is going to work because this is mine. And so I'm going to be there to ask you questions and have you ask me questions and to, you know, not really look over your shoulder, but to check and to be poking and saying, is this right or something like that. And so we had informal product owners for A3 and A6, like some things, right? Like the reaction wheels, it was kind of clear for the most part who owned them, but other things it wasn't so clear. And that was what we wanted to change going forward, is that we set up an organizational chart, or not a chart, but we organized the program in a way that we felt was the best of both worlds. It was not the sort of ragtag startup approach that we had been doing, and it wasn't the big oppressive systems engineering product, you know, management approach of big aerospace. And I don't want to put that down because that's oftentimes needed, although I'm not sure if that's the case anymore because SpaceX is kind of breaking that paradigm, but for a long time that was kind of what was needed. And we were like, well, we're a 70-person company, we need to do something in between. So we came up with what we thought was a really good approach to systems engineering for a 70-person company. And the unfortunate thing is that we didn't get to stick around long enough to determine whether our hypothesis was right.
Mm-hmm. So you do feel that kind of, I guess, if things had gone, you know, if things would have gone better, if Planetary wouldn't have run out of money and all that, the kind of team that was built and the approaches that were built and the systems and all the expertise that was there, do you think that Planetary was on the right track to do like a super ambitious mission? Like, I think it was like the first private mission ever to go to an asteroid, right?
Yeah, I mean, I'm sure that's a true statement.
Yeah, I
Because,
think that's how I remember it. So it was like a cool
yeah.
thing to be working on.
Well, I mean, there's a yes. I'm going to say yes. The team was amazing,
Mm-hmm.
and I felt like given um, the right direction to face, like the right objective, and you know, the right resources, the team could have accomplished it and done anything, for sure. And I thought we were well on our way to a good architecture and a good concept for our first deep space mission, this sort of asteroid prospecting mission. But with that being said, I I've never done anything that I didn't think was going to be much easier before I started than it turned out to be. Even making a video, right? I'm like, if I knew how hard something was going to be in hindsight, I would be a lot less motivated to start it. And so you sort of have to fool yourself into thinking, we can do this. I know this is going to be easy. right? And then you don't realize all of the things that just going to, you know, all of the roadblocks along the way and the things you got to learn and how hard it's going to be. And then you, when you finish, you're just like, oh, good, it's done, type of a thing. Never again, or whatever, until the next video. And we're like, oh, but this next video is going to be easy. Like that's my whole life. And so I feel like you have to have that, otherwise you'll be too demotivated right off the bat to even start something. And so would we have been successful? I don't know. I don't know, but we thought we were going to be, and that's the attitude that you need. Otherwise, you wouldn't have started it. And so we never got far enough to be proven wrong.
Mhm.
And so I'm still in that mindset that yeah, we could have done it, and we were well on our way.